Hello everyone. In this video, we're going to talk about the product rule. So the product rule is what happens when we want to find the derivative of two things that are being multiplied together. Now, in our previous sections, we could multiply the actual components to get 4x squared minus 12x plus 5x minus 15 combined like terms, and then we could, once it's like this, we can find the derivative using the power rule. But sometimes this is not practical. It's just too much trouble. So to demonstrate, we're going to do it on this lovely function that's nice and simple. And the product rule says that given f and g, which are both differentiable and thus continuous, we're going to find f prime times g plus f times g prime. And there's a reason why I do it this way, and you'll see that in the next for the quotient rule. So when we're talking about this, we would call this part f and this part g to have the two distinct values of the two pieces for this. And individually, we would find that f prime, so just this part, the derivative of x minus 3 is 1 based on the power rule that we learned before. And g prime, just based on f of x plus 5, once again, using the power rule, would be 4. So with this, we can use our product rule, saying that we want to do f prime g plus f g prime. So f prime is 1, g is 4x plus 5, and then we would add that to f, which is x minus 3, times g prime of 4, and combine and simplify. So we have 4x plus 5 plus 4x minus 12, and that would give us 8x minus 7. And then this would be our derivative of the whole thing. So even though we say f of x and g of x, and then we have this f of x in front, well, these are all just arbitrary names. So what they're talking about are the pieces versus the whole. So if this is our whole, the derivative of the whole would be down here. And this is part of why I use f prime g without the of x part, to help us distinguish ourselves of what is which in the pieces. And I relegate the f of x into the whole part. But that is a personal preference. It's not official. But either way, whatever it helps to do, that's what you do. Okay, so let's do this again. So we want to find the derivative of two things being multiplied. So when we have two things being multiplied, we can use our product rule. So I'm going to call this front part f and this back part g. So f prime would be negative 2x using our power rule. The power comes out front and then you go down a power. And g prime would be 3x squared minus 3. Okay. And now we can use our product rule. So f prime g plus f g prime. So do this section by section. So negative 2x for the f prime times g x cubed minus 3x plus 3 plus f 7 minus x squared times g prime 3x squared minus 3. So this whole thing would be our g prime of x of the whole thing. And we would multiply individually and simplify. So let's see here. we would have negative 2x to the fourth plus 6x squared minus 6x plus 21x squared minus 21 plus 3x to the 4 plus 3x squared, and then combine like terms. So we would have x to the 4 plus 30x squared minus 6x minus 21. And that would be our derivative of the whole thing. Okay? So that's how the basic works of the product rule. So let's do one that's just a little bit harder. So we have this lovely function, 9x minus 7x e to the x. Okay, well this has more than just the individual in our pieces here, because if we look at it in a certain light, k prime of x would be the derivative of 9x, and then the derivative of the negative 7x e to the x. So the derivative of 9x is easy. That's 9. But the derivative of 7x e to the x, this we would need our product rule for. Okay? So, if we call, arbitrarily, I'm going to call this part f and this part g. So f prime would be negative 7 and g prime would be e to the x. So we have k prime of x would be the derivative of 9x, which is 9, and then f prime g plus fg prime. So we have f prime is minus 7 times g plus negative 7x for the f times g prime e to the x, and simplify. There's not much to simplify, is there? But we can do this. Negative times a positive is a negative. So there we go. Okay. So let's do one more. Higher order derivatives. Now, once again, there's two ways to do this. Because of what it is, we have the multiplication of two polynomials. So on one hand, we could just go ahead and multiply the different things. And we could get 72t squared minus 54t to the negative 1. Right? 2 plus negative 3 is negative 1. So if we take away the product, we can just go ahead and use our power rule 3 times to get our derivatives. No problems. Or we could use our product rule. If they do not specify a method in which to use, then you're not restricted that way. Choose the way that makes the most sense to you, or choose the way that's easiest. I don't really care. But this particular video is about the product rule, so I'm going to do that. If we call this part f and this part g, then f prime would be 18t, and g prime would be positive 18t to the negative 4. Okay, so g prime of x would be f prime g plus fg prime. So f prime 18t times plus g prime. There we go. Simplify. So that's quick calculator, 144t minus 108t to the negative 2 plus 162 t. And then combine like terms. No, that's wrong. T to the negative 2, my bad. There we go. Now combine like terms. 144t plus 54t to the negative 2. And since this is now multiplied, we can just go ahead and use the power rule for the other two derivatives. So 144 minus 54 times 2 is 108, and then go down a power, negative 3. And the third derivative, that would be negative times a negative is a positive, 3 to 4, t to the negative 4. And there you go. Make the math easy on yourself as much as possible. But if they don't give you a choice, then you have to use their method. If they do give you a choice, then use the way that makes the math as easy to you as you can.